Welcome to our product setup instructions. In this video, we will show you how to use the MBC-DPIQ bias controller. Firstly, we need to build an EOM system. That includes the following components: laser, QPSK electro-optical intensity modulator, 10 to 90 coupler, MBC-DPIQ bias controller, signal generator, bench-top power supply, optical power meter. We need to wear anti-static wristbands before we start connecting the components. In the first step, we need to connect the laser's output to modulator's optical input port. In the second step, we need to connect the modulator's optical output port to the input port of the coupler. In the third step, we need to connect the 10% port of the coupler to the photodiode of the bias controller and connect the 90% port to the optical power meter. In the fourth step, connect the signal source and modulator with proper RF cables. In the fifth step, connect the controller's bias output port to modulator's DC bias port. In the sixth step, connect the controller to the power supply with a dedicated power cable. After the connection, now we can set up the parameters of signal source. In this case, we will apply a sine wave with a 1 MHz frequency, 0.5 volts VPP amplitude. For the power supply, the bias controller requires plus or minus 15 volts DC voltage as power input. We need to make sure the red wire of power cable is connected to positive 15 volts. The yellow wire of power cable is connected to negative 15 volts. And the black wire of power cable is connected to the ground port of power supply. After the parameter settings, we can sequentially activate the laser and signal source. And once the laser output and signal source output have stabilized, we can finally turn on the bias controller. We can observe that the LED of the bias controller flashes rapidly. When the LED becomes constantly on, it indicates that the bias controller has entered the working point tracking state. Moreover, the parameters of the optical power meter gradually converge to a certain value. We can see that the locking time of the bias controller is very short. The bias controller is working at null point mode in modulator's SHI, XQ, YI, YQ arm in default, and is working at quadrature point mode in modulator's XP, YP arm in default. And we can switch the working point polar by setting jumper on bias controller board. We can switch the working point polar by setting jumper on bias controller board. For example, we want to switch the working point polar of modulator's YP arm. We can turn off the bias controller, insert a jumper into the PL or YP pins, and turn on the controller. The bias controller has a reset port. We can insert a jumper into the RST pins and hold it for 1 second before disconnecting. You can see that the LED starts flashing, indicating a successful reset. The bias controller not only has basic operational functions, but also supports GUI operations. Here we will show how to use the GUI for remote control. Firstly, we need to complete the relevant driver installation according to the operating instructions. Then connect the bias controller to the computer through a USB adapter board. Turn on the bias controller. Run the GUI software. Select the correct COM port and click Launch. The GUI is mainly divided into two functional modules. One is operation settings, and the other is parameter reading. For example, if we need to manually set the voltage, we first switch to manual mode, select correct voltage output channel, then enter the expected output voltage value and click Set DAC. We can adjust the amplitude of dithering signals. Enter the dither amplitude coefficient in the text box and click Set Dither-Amp. And please note that this parameter will be stored in ROM and be automatically loaded when bias controller is reset or turned on. We can also read the DCV pi of the modulator. For a detailed introduction to other features, please refer to our product information. Thank you for watching.